let's look at biconditional statements. So consider the three statements that we have written on the screen here. We have that P is the statement that X is a multiple of 6. Q is the statement that X is a multiple of 2. And R is the statement that X is even. And what we're asked to do is to determine which of the implications is true. So for example, does P imply Q? So let's think about that. X is a multiple of 6. Does that imply that X is a multiple of 2? Well, yeah, if I think about that, it means X is equal to 6 times something, but therefore X is equal to 2 times 3 times that 3. So it is true that X is a multiple of 2. So that one's true. Going the other way, Q implies P. I would have X is a multiple of 2 implies X is a multiple of 6. That one's going to be false, right? Because just because I know something is a multiple of 2, maybe like 4, does not mean that it's going to be a multiple of 6. So we have to be a little bit careful here. Just because we know P implies Q, that does not mean that Q implies P is also true. So this is called the converse of P implies Q, and it's not necessarily true if P implies Q is true. So it's possible that one could be true and the other could be false. Now if we throw R into the mix, one thing that we might notice is that Q says that X is a multiple of 2. Well, that's the same as X being even. So if X is a multiple of 2, then X is even. And we also know if X is even, then X is a multiple of 2. So I get both of these implications. And that we can combine those two implications into a new implication. So I would write Q, and then I'd have an arrow going both ways, and then R. So this is my biconditional. We don't really ever call it a biconditional, right? We would call this an if and only if. And we'll see that on the next slide. Just sort of for completeness here, though, before we move on, we should also note that P implies R as well, but R does not imply P, just so we have all of those different combinations. So of the 6 pairings for these, 4 of them are going to be true, and the other 2 are false. Okay, so what do we get for this biconditional? So if I write P if and only if Q, or P with the arrow that goes both ways and then Q, that means both P implies Q and Q implies P. So both of those conditional statements are true. If you're curious how to get this symbol on tech, the command is /left right, because it's both a left and a right arrow. That'll give you that arrow that you want with the double lines in the middle. If you want it to look a little longer, you can also use /long left right arrow. So it's sort of personal preference between those two. The book uses this top one here. All right, so how do I read this statement? We've mentioned this a few times, right? We're going to call this double arrow an if and only if. And let's think about why we call it that. So if I break down the and, it's like I'm saying P if Q, and P only if Q, right? P if Q and P only if Q. we've seen, right, the if points to the thing that comes after it. So P if Q, that's the same as, we'll use let me use words here. So this points to that Q. That's the same as if Q, then P. So that's the same as Q going towards P. So that's this part. The other way, if I look at my P only if Q, that's the same as, remember this only if was one of the other ways that we could say if P then Q, right? The only way that P could be true is if Q is also true. So I need that Q because that Q is coming from the P. So we saw that this is the same as if P, then Q. Or maybe you want to think about it as if not Q, then not P, which again we saw was the same as this if P then Q. So that's actually my P implies Q. So the only if part gives me my P implies Q. And then the if part gives me my Q implies P. Seems a little backwards, but that's how they go. Okay, there's some other ways I can write this, right? So we've talked about this P only if Q a lot. We can combine that idea of necessary and sufficient that we saw previously to say that it's both necessary and sufficient. That gives us those either directions. Or, right, there's a couple different ways to state that. For P, it is necessary and sufficient that Q. Or P is necessary and sufficient for Q. I can also say that they're equivalent. They happen at the same time. And then we can also say and conversely. Remember this P, if P then Q, gives us that. And then I say and the converse is going back the other way. So when I say and conversely, I'm getting both of those things. Finally, I have a question for you guys to try. I didn't write it all in pink. Hopefully it doesn't throw anyone off too much. So I've got 3 different pairs of expressions. And I want you for each pair to decide if P implies Q is true, if Q implies P is true, and if both of them are true, then you can say that P if and only if Q. So go ahead, try all 3 of these, see if you can decide for each of them which of these 3 things are true. And then we'll talk about that in class.